All right, number 4 says a new model of the cell phone was released while the original model was still being sold. The average of the original model each week was $27.50, which decreased by 21% each week after the new model was released. Which function can be used to determine the average number, the original model of the cell phones, each week, X weeks after the new model? So this is a decrease, so this is going to be a decay. So we're going to use the formula y equals a times 1 minus r to the x. Let's plug in what we know. The original model, we started out selling 2,750 in the week. Decreased by 21%. So 1 minus, and change 21% into a decimal. Ready? 1, 2. So it's 0.21 raised to the x. All of these are already simplified, so let's go ahead and simplify this one. 1 minus 0.21 is 0.79. So there's my equation. It goes with answer B. Now, we have a few follow-along questions. So let's go ahead and take this one, let's graph it, and let's try to answer those questions. First, this one says, what is or what are the x coordinates? So where does it hit the x-axis? Well, if we graph it, or you should see from our facts of the plus k, but we'll go ahead and graph it anyways. So this is our graph, and we are not zoomed out enough to see it. So let's zoom out once. There we go. And you can see it's approaching 0, but it's not touching 0. It's the asymptote, which is going to be the plus k, but this k value is 0. So when does it hit the x-axis? Does not. Because the asymptote is at y equals 0. So it's never going to hit the x-axis. What are or is the y-coordinate? Well, the y-coordinate, the y-intercept, should be our initial value, right? So it's going to be at 0, 2750. What is the asymptote? We already answered that from earlier. Y equals 0. It's at 0. And what is the rate? Well, the rate is this percent. We changed to a decimal, so the rate is 0.21, or 21%. Is this a growth or a decay? It is definitely a decay. Those are just some facts. The question may be worded differently tomorrow, hint, hint, wink, wink. So make sure you know how to break this down. Okay, number 5 says, which graph is defined by the function of y equals negative 3 to the x? So you know what? I'm going to go into my graph. Now, to reset the zoom, you can just hit zoom and go to number 6, Z standard, or you can go 2nd plus 7, 1, 2, and reset it. Let's go to our y equals, and let's just graph it. In parentheses, 3 raised to the x. I'm trying to type it in exactly as it's written on your test. Now let's hit graph. We see one, it needs to be going down. The asymptote's right there, and it hits at negative 1. So, A, it's not facing the right way. B, it is facing the right way. It hits at negative 1. So, let's look at that one again. C, it's actually backwards. It doesn't work. And D, which is on the back side, is not facing the correct way either. So, it is definitely answer B. Okay, number 6. A sample includes 600 bacteria. After a dose of antibiotic, the number of bacteria decreases. Paula recorded the number in 20-minute intervals based on the dose relationship as given in this table. Based on this observed data, reasonably well-functioned fitted atom, which is a good prediction of the bacteria remaining after 2 hours. So, first, what we need to do is get the equation. Well, they already gave us a table, so we're going to go into Stat, Edit, and we're going to type in our table of values. So we've got 0, 1, 2, 3, 4. Then we've got 600, 319, 162, 70, and 38. Go back to Stat, go over to Calc, go to 0, exponential regression, and our equation then is y equals 622.806746. That is our A value. Our B value is 0.494831348 and we want to know what's going to be the value after 2 hours. Well, remember back here they're in 20-minute intervals. So how many 20-minute intervals are in 2 hours? Well, an hour is 60 minutes. That's 120 minutes divided by 20-minute intervals. That's going to be interval number 6. So we're going to, instead of x, we're going to use 6. So let's type this in our calculator exactly, and you can either graph this and find where it is 6, or we can type in the equation exactly just as a calculation. So I'll do both. So 622.806746 times 0.494831348 and raise that to the 6th. So there's one way, 9.14, blah, blah, blah. Or we can go into y equals, you could type it in exactly. And raise it to the x, and then you'll need to go into your table. And then we will need to find where x equals 6, and we still get 9.1432 on all those numbers. So what would be a good prediction? About 9. I'm going to stop the video here. We're going to answer the next few on the next video.